Good wishes. Let us walk through a presentation of converting infix expression into postfix expression. This uses the data structure of stack. And learning objectives of this video would be: it demonstrates the algorithm of converting infix expression into postfix expression. It finds the applicability of stack in it, and you will be able to convert any infix expression into postfix expression following this algorithm. And regarding the prerequisites needed to understand the algorithm is you need to understand between infix, prefix, postfix, and more important, you must be aware of the operator precedence rule, which operator has the higher precedence, and you must be able to demonstrate the operation of stack, how stack works, how push and pop takes place. And these are some examples that converts infix to postfix. Let us go to the first one. Here you find two operators, but two operators star has higher precedence, so it is converted first, forming 3 4 star postfix expression, and followed by plus. It is having a lower precedence than star, so now it is grouped like that, and it is converted as a postfix expression by placing the operator at the end. Hope you understand the simple example. And let us go with the next one. Here also we have two operators, plus and star. Even though plus has lower precedence than star, it is embedded within the parenthesis. So it is first converted. So 1 2 plus, and then the multiplication operator is considered, put at the last of the postfix expression. So this is how the infix expressions get converted into postfix. All the examples work with the same procedure, and you must know that no parenthesis and no precedence in the postfix expression. Let us have an example here. You will find a expression, and after it is fully parenthesized. You have a higher precedence operator parenthesis first, and then the lower precedence operators, and this is nested. So first a bar b is processed, then c minus c would be processed. So in the resultant you find ab star, ab bar, and c minus. Similarly d star you would convert it into d star, and it is grouped, yeah, a bar b, now it is converted into ab bar, and d star e, it is converted into d star. A star C is now converted into AC star. So these happens due to the operator precedence rule. And then comes the next one. Here is an example. You have an infix vector and postfix vector and a stack vector. You have to place and find out the algorithm. You must derive the postfix expression. So this is the given expression. For this you need to find the postfix expression, and to achieve this we have a simple algorithm outline. We are going to examine each and every character of the infix expression. We name it as token. If it is an operand, we are going to insert into the postfix expression. If it is an operator, if it is a left parenthesis, push into the stack. If it is a right parenthesis, pop everything out of stack until you find a matching opening parenthesis, that is left parenthesis. And also if it is an operator, if you find higher precedence operator, take them out and push the current operator inside. Otherwise lower precedence, you can just take it. It's very simple, and we'll see a more detailed explanation of this one. You have the first operator as left parenthesis, the code token is left, so push into the stack. Then next is a, it is an operand, so it comes into the postfix expression. So I hope you would follow. Then plus, it is an operator, so it needs to be get into the stack, so it is pushed into the stack because it finds a lower precedence operator left parenthesis inside. And b, it is an operand, so you need to put inside the postfix expression. Then comes minus. Minus and plus have the same precedence, so you have an equal precedence. If you have equal precedence, take the operator out of the stack and then put the current operator inside. So plus is taken out and minus is pushed inside the stack. Even though they are equal precedence, it is done. Higher or equal precedence, you can note it down the pseudocode how it is performed. And next is right parenthesis. C. C is an operand. Just put right parenthesis. You can recollect from the algorithm that whenever you see a right parenthesis, you must take all the operators out until it is until it we find an matching left parenthesis, right? So if the token is right parenthesis, repeat pop until you find a matching left parenthesis. And next is star. This is a simple case where you push the operator inside the stack. There is no other operator to be checked, but anyway you have to check inside the stack whether you have an higher precedence operator, but currently you don't have anything, so you just push inside the operator the stack. Then D is an operand, so it is pushed into the postfix vector, and minus, it is again an operator which has a lower precedence than star, so star is popped out of the stack and added into the postfix expression, and minus is pushed inside, and opening parenthesis as usual put inside E operand, so it is loaded into the postfix expression. Then you will see a plus. What would be the place of plus? Can you guess it? Yes, exactly. It goes into the stack. Another condition of checking out. Then F is again an operand, so it is added. And at last you have an right parenthesis. Whenever you see a right parenthesis here, you need to pop everything till the left parenthesis, so everything taken out. And now the infix expression is empty, so take everything out of it, and finally it forms the postfix expression. Hope this is a very easy algorithm to understand. This is an elaborate algorithm where you could study everything. You must read the tokens first. When token is an operand, add it to the end of the vector. This is a very easier step in the algorithm. Next is when token is a left or right parenthesis or an operator. First case is if the token is left, just push back the token x to the end of the vector. So that is nothing difficult. If it is left, just push inside. If it is right parenthesis, just you could take everything out of it and until you encounter a stack. And then the third case, if it is a regular operator, you have to check the stack vector. You need to take out the higher or equal precedence. You have some cases, step 1, and in step 2 you have some 3 cases. So the first case is stack vector not empty, the second one is it is not left parenthesis, and third one is it may be an operator of higher or equal precedence. So in those cases you must pop everything and then push the current token. See, you can understand you are interrelated with the keyword logic and logical operator and, but in the case of lower precedence you are with the logical operator of or, because it is directly pushing inside without popping. You are directly going to push inside. So if it is empty or if it is lower precedence, you are going to just push, and when all the things are processed, you just pop everything from the stack into the postfix vector. So this stands the algorithm where you must find for the operators. Let me give you an example. Just you can take a couple of minutes to solve this. right? You may get this as an answer if you are very much well versed with the conversion. If not, please recheck your answer, and we'll see how we derived at this postfix expression using our algorithm, right? This is infix token. A is an operand. It is put inside the postfix. Then minus. It is pushed inside. B operand, and this is an higher precedence, so pushed inside. And the next one, exponent equal precedence, so one is taken from the stack and the next one is pushed inside. So it is taken into the postfix, and from here it is pushed inside the stack. And next is left parenthesis, it is pushed inside. D is an operand added, and minus, it is pushed inside the stack, and left it is pushed inside. E is added to the postfix, plus again it is pushed inside. F is an operand. Star is an higher precedence operator, so again it is pushed inside the stack. And G to the operand, it is an operand, so to postfix vector. And right parenthesis, so you must pop star and plus for the first right parenthesis, and the second one you must pop minus. And next star, it is a lower precedence than exponent, so exponent is taken out and star is pushed inside. And now H is an operand. After all it is completed, now the complete stack is popped out, giving out the end expression. Thank you for listening to this, and this may be your reference work. You must find the application of postfix expression in calculators, in stack-based programming languages, and in data flow pipelines. Please refer how the postfix expression is used in all these applications, and you must be aware of what are all the stack-based programming languages too, and how do they get used in data flow pipelines. And in classwork, we may be discussing with how can the algorithm change to find a valid infix expression, and you will be asked to modify the existing algorithm so that you could find out the infix expression, and you may write a C or Java program which implements the algorithm, and we shall discuss the applications that you have referred to. Thank you for listening to this video. Hope you have got some insight into the algorithm. Thank you once again.